Welcome, everyone, to this week's installment of the Waku Vibe Coding stream. I am Chair. I'm here to prop you up. Right over there is our host for today, Arseni. How are you, Arseni?
I am excellent. Besides a small hiccup in my lower back, I'm feeling great and ready to vibe.
Backs aren't supposed to hiccup. I hope you feel better in that regard. I'm excited to get into it today, handing the reins over to you. Folks, you are watching us either on Twitter or YouTube or in the Discord. Wherever you are, if you can like, retweet, share, drop your questions in the chat. let me know if the audio is good or otherwise. And without further ado, the esteemed Arseni.
Give me just 1 second to figure out where the where I'm getting the echo of our audio. What I'm mostly looking for is why I'm getting I'm hearing the stream delayed in my headphones. Just give me 1 second, please.
Take your time. Thank you for being here, folks. We'll get the technical difficulties sorted as such and thusly. In the meantime, you can visit waku.org. You can go to docs.waku.org. Waku.org on YouTube. blog.waku.org. My point is, ladies and gentlemen, is that there is an abundance of material, both audio, visual, and literary, technical specifications, blog post, forum post at forum.logos.co, technical forum post at forum.vac.dev. My point again is that there is an abundance of documentation, specifications for both Waku and the greater Logos core stack. Now for folks,
Should be good now. Yeah, I got waku.org here up on the screen. You want to throw that on? Our beautiful statue of Mercury, the god of communications. Yeah,
I believe
please
that is
check us out.
Hermes.
That is the Greek. The Romans called him Mercury.
Well, I am a
Same dude, different name.
I'm not a Philistine. I just
look at it. Look at him. Look at him
crush a lot.
spin. Look at him turn. Anyways, for those who don't know, Waku is a protocol for uncompromising peer-to-peer communication at scale. And what that basically means is it allows a way for internet-connected devices to communicate with each other without relying on a centralized intermediary and while protecting their private data, including metadata. It is a critical part of truly building, what we've been calling Web3. And I'm extremely privileged to be a contributor to this project, and I'm extremely lucky that I get to showcase it today. Give me a second here while I switch over back to my whiteboard. Now, for those who have joined our sessions before, on the last one, I went deep into Claude Code, some of my philosophy around, how do you prompt? How do you think about prompting? How do you properly contextualize a problem or the project that you're working on for an LLM, whether it's Claude Code or whatever? They're all, they all have a similar interface, which is you input text, it outputs text. Great, smart application developers have figured out how to hook that up directly to, the terminal and your local file system, and actually have it work as a agent, they call it, and make edits and all that. And a lot of this stuff is getting very, very hyped, both in terms of noise, signal, and funding. But at the end of the day, a lot of the principles and strategies around it are nothing new. And I think a lot of it just comes from, proper preparation for building a software project, whether it's vibe coded or not. Can we get the whiteboard up on the stream again? I should be sharing it now. There, sweet. Okay, so why am I in a whiteboard and why am I not in Cursor or Claude Code? It's because I don't know if you've all heard of the idiom "measure twice, cut once." Well, it definitely applies to quote unquote vibe coding. If you just jump straight into prompting, it's very possible that you're going to create more trouble for yourself than if you had just started coding. And similarly with coding, sometimes if you jump straight into coding, you're going to create more trouble for yourself than if you stopped to think about, okay, well, what is it exactly, I'm going to build? What is this going to look like? I have found that using, charts with some kind of basic notation, it doesn't have to be, anything formal like UML and all these other ones. Just something that works for you that you can quickly communicate to other stakeholders or developers can help a lot. And this is one of the sort of charting or notational languages that I've developed for myself that I found pretty useful in creating this like top level understanding of what exactly is going on. The core unit is this little parallelogram, and it represents a data type. So it doesn't necessarily usually it means one or more instances of that type, but it also means like a distinct data type. So this could be a string, but usually I give it a name that both, sort of indicates what its like primitive type could be, but more likely than not, it's contextualized to the situation. And different colors indicate special data types. So I try to model everything as functions and processes that have an input optionally, an output optionally, and then this is a successful result or an error result, but minimum a success result. A function means typically like a single unit of computation, for lack of better words. So for example, or maybe not a single unit of computation, but like on a more conceptual level, like just the simple filter for null, that would probably be a function. But when you have something more complex, that should be defined as, a process. Filter and map this is a super basic example. And you typically have data always flowing into a function, because either the data is ready to be returned or you need to do something with it. And then either you can do a small thing with it, with a function, or you need to do a bunch of things with it as part of a process. And then typically input data is coming from users, so from clients, but more often than not, it'll end up, in a data store, or will be part of a queue. So I try to keep these relatively abstract while still being discrete enough to actually be useful and actually be useful in modeling on a conceptual level systems of software. So for here, you have a data type. We can say that this is, set of user messages that I guess are potentially null. You filter for null, and then what comes out, I want to be a different conceptual data type. Most likely the filtered messages are still an array or set or vector or whatever of some kind of message type, and it's the same message type in the code for both of these. But on a conceptual level, I want to understand, like, okay, I had these messages, they came from somewhere, I filter them, and then the result is filtered messages. There's some transformation has been applied to them, and that, like, anything that was null was emptied. And I mean, this one's pretty basic, but we can still be explicit about what's the input, meaning what comes from outside of this context, and then what's the output. What does this process provide to the rest of the system? And we can say that all of this can kind of be represented here. Usually we want to include like a couple more. So for example, typically, like, you want at least two functions in a process. So filter for null, and then, I don't know, you can sort by age or whatever, or sort by time. In which case you have an intermediary data type. Intermediary meaning that it's not, used outside of this function. It didn't come from outside of this function. It's not going to leave this function. But it's still useful because we want to be as explicit as we can. So here is the minimum example of how something like this could be used. And then finally, you want to do is capture all this under a single, let's see here, what do they have for us? Oops, my bad. There should be like a little, whatever, we can just make a big one like this. Oh, interesting. probably not the way we should use it, but actually, I kind of like this, having the inputs and outputs at the ends here, and we can say that, like, okay, this is the filter and sort process, something like that. Okay, so now let's actually. I hope that's relatively clear. Are there any questions, Chair? Does anything seem weird to you about this?
That's making sense so far. No questions yet in the chat, but feel free to drop them, folks, wherever you might be watching. In the available chats, we can see them. But so far, nothing. 82 live listeners as of right now across all the platforms.
Okay.
Back to you.
That's awesome. Welcome, everyone. We're doing some vibe coding. We're starting with vibe boarding. Basically, the planning process of what you want to do before you jump into actually vibe coding. Here's the legend for their chart. And now the fun part is we get to come up with what exactly do we want to build. So at the last vibe coding session, we got a template going that uses both Waku and Codex. And that was great to sort of demonstrate my approach to writing the actual prompts. But now I want to think about, okay, how do we take it a step further? And you know what I'm going to do? I am going to pull up Troll House Troll Tales, which is a project by the exceptional Václav Pavlin, which I believe he had also created during a vibe coding session.
Just to double check, you are not sharing your browser at the moment.
No, I mean, the whiteboard should still be there. I'm gonna set up real quick.
Yeah, you can zoom in just a touch more on your whiteboard too, but otherwise looking clean.
Okay. Do this. Can delete. Bear with me, folks. I'm just I had my tab shared, so I have to switch to sharing my whole screen.
While we wait, if you are viewing on Twitter, please go ahead and like and retweet the broadcast. You can drop your questions, even as simple as "What are you doing?" in the chat. So Arseni searches for the correct view for you. We are doing Waku vibe coding sessions once a week, live all over the place, live right here wherever you are experiencing this.
Okay, it should be good now. Can you see it? Is cursor visible?
Cursor is visible.
Sweet. Okay, so I have cursor open with the Troll House Troll Tales project. I see it was made with Lovable. Lovable is not bad. I think it's great for getting stuff up and running. It's pretty opinionated. I think it only does React. Replit is pretty good too, but yeah, I think you'll find with these that it's great to get something simple. It's great to have something visual that you can look at and, you know, get that sort of feedback loop going. But I feel like they start to struggle once you get into anything more complex. And really, even, you know, the best agents, I think, will struggle because of contextualization of, you know, how do you continuously communicate to an agent about the dynamic tasks that you need to accomplish. And obviously one way to do that is to, actually have your own understanding of what it is you're hoping to do. So for those who don't know, the Trollbox is, if you remember, if you ever used like Poloniex back in the day, the crypto exchanges would have these little chat boxes that you can use to you can just use to like chat with people while trading. People will try to pump their bags there or whatever. And this project provides a very easy way for someone to add a troll box to their project that uses Waku. So it doesn't rely on setting up a server or any of that. And it's extremely useful because if I recall correctly, like Vaslav had set it up, perhaps it's not here, that there's like a one-line install you can do in your React app that adds this to your project automatically. You don't even have to worry about setting up infrastructure because it's going to connect to the Waku network.
That is correct. There is a one-line NPM package that you can just add to your app.
Okay, so now I've got both Claude Code and Cursor. I don't know if I'm going to do too much actual prompting inside of Cursor, but yeah, I'm just having it run and build the project for me, while in the meantime I try to take a look myself of what is being done here. So the query client, that's just a standard query client. I'm trying to look for the Waku specific components. Guessing it'll be on this index page. Yeah, so we got hero, we got an about section, something about privacy wisdom, community values, a footer, and then the troll box itself. This is probably the most important one. Oh, interesting. It's a separate, I see. So this is the demo project, and this is the actual troll box component in here. Okay, that makes sense. Yeah, so like I was saying, decentralized chat component. Oh, it even has Web3 wallet integration. Interesting. I didn't know that. Yeah, and so the reason I'm in here is I want to see if I can take this existing project and like develop an understanding of it before I try to, improve it using LLMs. Before you can add a feature to an existing code base, you got to have a pretty solid understanding of what exactly is going on. And so let's try to have the agent help us with that. So for more conceptual kind of exploration tasks, I usually switch to O3, at least through Cursor, through O3. I've been getting good results. And we could say something like, I'm just going to zoom in so we can see my prompt screen here. Help me understand this package from a conceptual and architectural level. You know what? What if I wonder if it can pick up on what I'm trying to do with this charting language. that I've kind of come up with. So why don't I just take a screenshot, toss it in here, and say review the legend and example of a diagramming style, I guess, in the attached image. Use that to guide how you think about this repo. Focus on the core data types as well as the points of interface where users input data as well as the points where the application connects to the Waku network. For now, let's assume messages received via the Waku filter protocol can be treated like a queue. Which isn't totally accurate, but I think for our purposes, it may be sufficient. I've actually never tried this before. I've never thought of, taking a visual language that works for me and then just trying to have the agent reason about it. So let me zoom in a little bit so we can see what it's thinking here. Oh, it went away. But yeah, these are interesting. I like sometimes when it gives you these little insights into its quote unquote thought process. It's not really a thought process in my opinion, but yeah. And while that's going here, yeah, sometimes it'll get stuck when you're opening a repo for the first time and it doesn't know whether it's allowed to install dependencies or not. There's ways to I believe you can set like default allowed deny lists for commands across all your repositories. I haven't done that yet. But yeah, you can see here that when you use O3 and you specify like a more kind of deep thinking task, I guess, it'll make a plan, and then it'll go through and read the different files either all at once or in pieces. And yeah, hopefully it uses that to give us the answer we want. I was talking earlier about contextualization. I think the reason that these agents becoming more popular is because the feature that they provide is basically like automatic contextualization. I didn't tell it to read Waku service.ts. I didn't tell it to read ENS service.ts. I could have, but in this case, that was the context that I didn't want to provide, but that I wanted it to kind of tell me. And so instead, the context that I provided was one, like, what do I actually want? And I specified conceptual because I wanted to, I don't want it to just like show me code or talk to me in code. I wanted to see if I can even challenge O3 to take the code and understand it differently. And then I also contextualized it by giving it a legend and the diagram style, right? The one I developed on the whiteboard. And what that tells it is make the output try to shape the output into this form. If you don't tell it how you want your output to look like, then it's going to make assumptions. It's useful that the LLMs make assumptions because it saves, it's part of like the appeal. It saves you, the work sometimes of having to read and think about certain things. But we want to limit the assumptions that it makes as much as possible. Similarly, that's the purpose of this here. Focus on the core data types, the points of interface where the users input data, and points where the application connects to the Waku network. So I've given it, I've given it some tools. I've given it a bit of a map, and hopefully it uses that as well as possible. Okay, so core data types, Waku message. The React side equivalent of a Waku message, wallet info. And it even gives you links to the code base. That's pretty nice. Okay, so Waku message. Maybe, I don't know how accurate this name is, but let's see. Let's see how it's used in the Waku service. Ah, yes, the dispatcher. This is another abstraction that Václav has developed. And it's almost like an API over a lot of the common JS Waku patterns and functionality. Okay, so this on its own hasn't helped me much yet. You can see that there's another message type, and this is the one that's actually passed to the interface. Some wallet info, an internal ENS cache, and I believe that's what's used to. Okay, I remember now. Every message in the troll box is signed using the user's wallet, and then is broadcast over the Waku network. And anyone who receives these messages, each client verifies the signature. And I guess if there's an ENS name associated with that address, it has to check ENS for the human readable address, and it caches them into local storage so that that check doesn't have to be performed over and over. It is critical for the sake of decentralization that this check happens in the client. Both the verification of the signatures of each message and the ENS mapping. Input interfaces where users inject data. So we have a wallet connection component, like most dApps, pretty standard. And then the message, the troll box component is where people actually put in their messages. Text plus emoji. It calls a function which actually takes it from the React HTML inputs, turns them into the Waku message. It's optionally signed. I guess you can have unsigned messages, and then as the client, as the user, it's up to you to decide, okay, do I care if people are sending messages without the signatures on them, or do I only want to allow messages for which I can verify the signature. And then after, the data is converted from, how it's captured by the interface from the user to turning it into what it needs to look like to be broadcast over Waku and signed. Then it gets pushed to the dispatcher, which, interesting, it lazily spins up a Waku light node, which means that it might not start the node until the user has done something to indicate to the app that, okay, like we probably want that light node up and running. So this stuff, I don't know if I've seen apps that lazily spin it up yet, but that could be useful. But all this is, this is pretty standard for apps being built on top of Waku. And then the dispatcher is an abstraction over, like I said, over a lot of common patterns. And we're probably we're definitely gonna have in quote unquote official Waku API that will provide a lot of these. We are going through the process of like formalizing a lot of these common patterns but we've seen, from building apps ourselves, and we've seen from, other people who try building on Waku. And as we identify them, we're going to continuously integrate them into a library. Content topic, registers key, subscribes to events. And then when we send messages, it uses light push. Similarly, there's a filter subscription where we receive messages and they're going to an app ID or hostname derived content topic. And then, the incoming paths, how we receive messages. They come in through the dispatcher, detected by the Waku service. It calls the handler, and I'm guessing either there or in the Trollbox component is where the data type is converted to what's necessary to be rendered into React. And then we have local persistence caching. Another really, really important component of peer-to-peer applications. And that definitely important for applications that leverage Waku. And then the render loop. Interesting. Okay,
we have a comment from Václav coming in hot from Twitter. He says, I would absolutely love to watch this detailed dissection of my shitty vibe coded code, but I'm tired and it's late. Don't hate me too much. Sorry for all the inflicted suffering. That is from Václav Pavlin, the Waku Solutions engineer who vibe coded.
Václav, when you listen to this, if you're listening to this, I appreciate your concern, but don't worry, I'm not reading it anyways. The LLM, the LLM read it. An LLM wrote it. I'm gonna make an LLM read it. But okay, now I don't know if there's an easy way to get these into the whiteboard thing I'm using. Probably not, but you know what I can do is I'm going to hopefully I don't leak too much right now. I need to pop open Claude here because they have a very useful artifact functionality. And what I can say is take this report and use the description of the system as well as the opinionated modeling opinionated diagramming strategy to generate a single page artifact that renders the described diagram. And then I'm just going to paste all that. And it's going to have, once it finishes this, it'll have something we can actually look at. And then if it's good enough, I'll copy it in the whiteboard. So it would be really cool if it can go, if it can generate it in the format that I wanted exactly, but it doesn't know how to do this, or at least it's not the most effective way for LLMs to generate visual materials, especially diagrams. It's most likely, in this case, it's using SVG, but I've had it use, I guess I could have asked it to use Mermaid or whatever, but yeah, it's gonna be really interesting to see if this is useful. Like just reading it, just this kind of guide that it gave me was already useful, and I can confirm that it's useful because we'll actually have experience working on JS Waku and like building apps on top of it. And like, to me, most of what it's saying makes sense. Even the parts I'm not sure about or that I'm only like semi-familiar with, like the dispatcher, it seems to me that like it did an accurate job. And I guess this goes back to my earlier point about measure twice, cut once. You can have the LLM be part of that measuring process, both for yourself and for the agent, so that the agent now, has additional context. So back in the Claude Code instance that's in the terminal, I'm just going to have it run tests and make sure that everything is built and installed normally. I told it to earlier to just like build and install the project because I'm too lazy to check the README or check the package.json. I don't want to like dick around with, do I just install? Do I install and build? Do I install and run something else? So just let Claude figure that out. And it did that while, we were just having this other instance read the code. Let's see, how's our diagram looking? Let's try to get fancy with it. Look at all these highlights. I guess that's kind of right. It didn't quite get what I wanted to do here, but yeah, no, this is not useful. It kind of did it, right? You have the light push protocol, and that's how we send. It goes to the Waku network, and then the filter is how we receive from the Waku network, but the other stuff is kind of out of the way. So what I'll do is I'll just have it try again using, I believe it's Mermaid. So Mermaid is better because it's a formalized charting diagram. So you can represent like the visual arrangement of elements in a deterministic way. So it provides additional constraints on the output. So another key term you'll probably, hear me use is constraints on the output. It's arguably the most important part about prompting is, what do you want at the end of this? You're gonna use marvel of modern technology to make a request to the most complex networks of computing devices ever manifested. You should probably know what you want, what you want in return. This looks way better. Let's here, in fact, we can even publish it. It's the best way. Here, Chair, I'll send it in the in our private chat that I'm showing everyone here. If you wanna share that right quick. Oh, it broke. I closed it because it broke. Sometimes the charting can be not the greatest. Just the interface, but let me. Oh, come on. All right, well, you can look at the full chart later, but it does seem to be a lot better than the one before. And still captures like the key. And it's honestly it's like a little bit like revelatory for me as well. Like this little flow is just so core to like all the apps that people have been building so far. Anyways, any questions so far? I know we haven't made any like actual code changes, but all of this honestly, like, I think is some of the more valuable information that you can give to potential vibe coders. Whether they're going to be vibe coding with Waku or not is, how do you prepare yourself and the LLM for success? Yeah.
First, I'd love to implore the audience to ask your questions. I'm pretty sure you have some, and this is a great opportunity to have Arsenie's ear. My question, if you could summarize briefly the process that you've gone through up to this point and why, and sort of the objective of each step in the context of why it makes your life easier or what the end result, how it might affect the end result by following this process specifically.
Yes, let's do that. So what did we start with? I started with the whiteboard, and I started with establishing a semi-formal diagramming language. People have a lot of opinions on this, and at the end of the day, you should do what works for you. But ideally, you come to consensus with like your fellow developers that, yeah, like this is a useful way for us to represent our system. But even if it's just for you, it's a useful exercise to take to make sure that you understand what's going on, and or that you understand like what you want to build on a conceptual level before you even sit down to write code. And so I kind of just went through the legend of what this means and how to use it to represent data flowing through functions, abstracted into larger processes, and ultimately either being input by clients or grabbed out of queues, grabbed out of or sent into queues, or grabbed out of or sent into data stores. Then I went into the project, the Troll House Troll Tales, and I had O3 use that legend and diagramming style that we developed to actually help me better understand this repository. I specified conceptual and architectural level. I attached a screenshot. I believe it was just like this whole section here. And I told it to use that. I told it to focus on the core data types. That's always, our diagramming style is focused on data types, so it makes sense that I'd want the LLM to use that in its conceptual exploration as well. And I specified points of interface, both where the user inputs data and how the application connects to the Waku network. Because for most applications, it's going to be that. There's going to be some point where the user inputs data. There's a bunch of stuff that, either a bunch or not a lot of stuff that happens in between. And then that data is sent somewhere else. In this case, over the Waku network to other degens who are, using this DeFi app that has this Trollbox installed. And then I just gave it some additional context here. I told it, let's assume messages received via the Waku filter protocol can be treated like a queue. The reason I did that is because this, by default, it's not going to know everything about the Waku protocol, and it might not even know like how it's expressed in JS Waku, and it might start telling itself like, oh, hey, I got to figure out like what this means. And instead I know that it might do that. And so I want to tell it, look, just assume it's a queue. It's both because it's like a simple way to abstract over this component, and also because it fits with the diagramming language which I gave it. It fits into the structure of the output that I want. It did that. This is agent mode in Cursor using O3 that they claim is better for complex problems, difficult bugs, deep reasoning, slow. And it went through, it thought, it read, and then it gave me like a pretty good overview. I read the overview, and based on my understanding of Waku and my understanding of what this project aims to achieve and my understanding of building applications with Waku, it did an accurate job at understanding the flow and at like representing the flow to me. Like specifically, like I like knowing this specific flow in this format for any application I work on, or any code base I work on. And this is like one of the biggest benefits of LLMs is I don't have to. I was gonna start like just going through the project and like building this out, but then I realized, wait, why don't I just have it do it for me? And the reason I even go through this charting process, sometimes it's not even for the purpose of having a chart at the end of it, but because if I can make a visual chart of a bunch of code, then I'm proving to myself that on some level I have a conceptual understanding of how it works. I have an understanding of the system that's not fully dependent on how it's expressed in the code. It's always tricky bridging the gap between the two, but it's not, there's only so many ways you can do it. And so, and maybe, different people have different different ways of conceptualizing code. And the great thing is you can tell the LLM, like, okay, well, show it to me in these terms. Yeah, if you're used to, if you're used to, I was gonna say writing in like Fortran or COBOL, you might want a different, you might want it explained in a different using different concepts. But yeah, point is
that I am not. Writing in COBOL. No, I would just wanted to say that following this process and just overall your tips and listening to your flows has helped me immensely and exponentially in the quality of the output that I get from my dealings with the LLMs. Especially with these diagramming and screen, a huge breakthrough was screenshotting things and feeding images more for context. But really, this entire flow is great. So keep listening, folks.
Screenshotting is OP. Yeah, screenshotting is extremely useful because it is just great to save time. Like, it was perfect for this because I had described the legend. I had described how this worked, but I had done it as I was doing it, as I was like demonstrating it, over the stream. It was very natural. And at the end of it, the problem is that I didn't have anything I could give to the LLM. I mean, unless we had stopped, found the transcript, turned the audio into a transcript, got the text. But I guess this was sufficient for it to just this screenshot and the additional context and the code was sufficient for it to give me what I wanted. Yeah. And then we took the output from this LLM and we put it into Claude and asked it to generate a single page artifact. So this is a strategy I use often, specifically with Claude Web, specifically this artifact feature, when I want either something to be made visual or something to be made basically like stylized. Like if I want, if I had an LLM generate me a markdown file and I want to share it to someone, I might paste it into Claude and say, like, make this look like a single page, report with a clean, minimal business style or whatever. But the interesting thing here that we saw regarding visual diagrams is when I just asked it to give me a diagram and it used SVG, it messed up. But then when I tried again with Mermaid, it did a much better job. And it's because, Mermaid it's a programming language. There's only so many things that it's able to, there's only so many ways that you can like arrange elements through Mermaid versus, if you're using SVG, like it's completely arbitrary. You can draw whatever you want. So yeah, constraining the output, that was the other big lesson of the day. Is you want to think about what output you want, and you want to constrain the LLM as much as possible. A programming language is a great way to constrain it because it can programmatically tell it that it's not correct, that like the code won't compile. Yeah, and then another great constraint is obviously MCPs, the Model Context Protocol. But that's a whole other topic. As I mentioned earlier, my back is a little sore, and I think this is actually a good place to end because like this process on its own, I think will be valuable for coders and vibe coders alike, whether or not like you can go through this process and then if you decide you're going to vibe code something, or if you decide you're going to classic code something or whatever you want to call it, either way, this should be helpful for you.
Yeah, this is perfect, and I think it's a great breadcrumb or tease for folks for next time to tune in on the next stream when you will be with us, Arseny. We do have Václav coming on, Frank, Danesh, and Really, I would love if we could get every single Waku engineer that wants to come on. But those are scheduled in the coming weeks. Arseni will have you back just as soon as you want to be back. Thank you very
I'll be
much.
back.
So
I'll
part
be
two,
back.
part two of this saga. will
Wait, Chair,
continue.
I'll be back. Chair, I'll be back. Look, you don't have to worry. I will be back. I want all the listeners to
You
know.
better be back.
I will be back better. I
That's
will
what
be
we're
back
looking
better. Because this is Waku vibe coding, and we're not going anywhere. We're here to build the decentralized infrastructure for the next generations and the next generations after that.
And we are excited about it. .org is where you can find all of the information and descending links. Join us in the Discord. Follow us on Twitter. Subscribe to the YouTube channel. Most importantly, read the docs. Implement Waku in your application. Today, what will you do with Waku? Thank you, Arseni.
Thank you, everyone. Have a wonderful day, evening, night, wherever you are.